All right, so I think I figured out how to fix that annoying echoing that you guys have been experiencing during the last couple of videos. And so we'll try this out. Hopefully it works. All right, so the next 3 lessons are going to involve different ways to organize and display data. Today and tomorrow are pretty similar in terms of looking at like how the data is distributed as well. And so what box and whisker plots and histograms, which is what we'll do tomorrow, are ways to organize the data quantitatively. All right, so quantitative means like numerically and kind of more analytically, as opposed to that is definitely not spelled correctly. Quantitatively, in terms of like analytical interpretations and stuff like that. Okay, so a box and whisker plot is called a box and whisker plot because it's made up of these 4 different pieces: 2 boxes and 2 whiskers. Now, the boxes and whiskers usually will be different sizes, and that is how we interpret data based on the box and whisker plot. And so what a box and whisker plot uses in order to organize the data is called a 5-number summary. And that 5-number summary is made up always the lowest value and the highest value. So that's going to be the ends right here. And then these 3 like bars right here, which we'll talk more about here, but this is going to be called the first quartile or the lower quartile. This is going to be Q2, which is the median of your data, and then this is the third quartile, or you might hear like the upper quartile, or like just Q3 is kind of the abbreviation for it. Okay. And so what these 4 little sections do is divide your data into 4 equal parts. So for example, if you have like 20 pieces of data, each little section right here would have 5 pieces of data in it. And if it's not evenly divisible by 4, your medians will look a little bit different, which we will talk about when we run into that. And so then what we do is you always find the median first. Okay, so that's the middle value of all of your data when it's organized from least to greatest. And then you take each half, right, because the median will split it in half, and you'll have the lower half and the upper half. And so Q1 is the median of the lower half, and Q3 is the median of the upper half. And so we'll come back to this outlier. I had already written this down just to kind of save some time, so I don't want you to necessarily copy down that quite yet. And so I also saved some time here in this first example, and you can kind of see, since I'm re-recording this, I erased my original box and whisker plot, writing over it again. Okay, all right, so since a box and whisker plot organizes data using essentially 3 different medians, your first step is always going to be to reorganize your data in numerical order. Okay. And so what we're going to do now is we are going to find the median of our data. So we need to figure out what that value is going to be. So I'm just going to start on the ends and work my way in. 2, 3, 4, 5, and so if I go in 6 more, I don't have necessarily one value that's the median. So remember, when you have 2 values in the center, your median is going to be the average of those 2 values. So 25 plus 25 is 50. 50 divided by 2 is 25. So I'm going to go ahead and I'm going to draw a line right here to separate my data into 2 equal pieces. Okay. Now, there should always be an equal number of data values on the right and on the left. So if that 30 had not originally been there, this last 30, when we would find our median, we would go, let's see, in. So that value right there would be the median. So we would have drawn a line through that to have, what would that be? 5 values on either side. So you should always have the same number of values on the right and left of Q2. All right, so now what we're gonna do is find the lower quartile and the upper quartile. So this is the lower half of our data. So I'm gonna do the same thing here. I am going to work my way in, and I work my way in again. So I don't have one value that's the median. I have to find the average of these two. So 21 plus 24 is 46. 46 divided by 2 is 23. Or you can kind of just look at that and say, oh, 23 is going to be exactly in the middle. So that's going to be my lower quartile. And then I'm going to do the same thing over here. So here's my upper quartile. So when I work my way in, the same thing happens. I get 28 and 30 as my two middle values. So that means that Q3 would be 29, halfway between 28 and 30. So it is possible that your quartiles may end up being decimals, like 23 and a half or something like that. That's okay. So what I want you to notice before we draw it is kind of going back up to the definition of a box and whisker plot and how your data is organized. So we originally had 12 pieces of data, and when we divided it, all 4 of these sections now have 3 values in it. And that should always be true. So when you're looking at each little section right here, you should always have the same number of values. So if you have to like put your line over one of those values in order for that to happen, when you're finding the medians, then that's what it'll come down to. All right, and so now what we need to do, I kind of skipped this part of the definition too. You always use a number line when you're displaying your data using a box and whisker plot. So the next thing we have to do is figure out what we want our intervals to be. So since my lowest value is 18 and my highest value is 30, that's only a range of 12. Remember, your range is the highest minus the low. We haven't really defined that yet, but most people usually remember that from middle school or whenever you guys learned it. So since the range is only 12, I'm gonna go ahead and just go up by 1. If your range is bigger than that, you are free to go up by like 2 or 5 or 10, whatever you need to be. Just make sure you're always like labeling your quartiles in the 5-number summary, because you're gonna have to approximate like the distance between the 2 points. Okay. But I'm just gonna start here at 18, then go 19, 20, 21, 22. And then all the way up to 30. And you want them to be approximately equidistant from each other. You can see I kind of got a little bit messy in here. They're not the exact same length, so just kind of do your best. All right, and so then we're gonna plot everything that we found. So my lowest value is 18. My first quartile is 23, so 19, 20, 21, 28. 18, 19, 20, 21, 23. And then, so I'm going to draw that first little line right there. And then Q2 is 25. So I'm going to go ahead and draw that right there. And then Q3 is 29. So I'm going to go ahead and draw that line right there. And then my highest value is 30. So that endpoint will be there. And then we'll just connect everything. Okay. And so that would be my box and whisker plot. All right, so in terms of some of the things that this tells you, and we should probably label this too. So this is ages of backpackers. So we want to know what those numbers mean. And so what this tells you is this breaks our data down into 4 sections. So each section represents 25% of your data. So the visual part of this can be kind of tricky for people because these 25% are all different lengths. And what that tells you is how the data is spread out. So when we look at the top 25%, the range is only 1 year, right? Because Q3 is that 29 right there. So we're going from 29 to 30. So that just tells us that the top 25% of our data just isn't really that spread out. But if I look at the lower 25% right here, this range is 5 years. So this kind of tells us here, and we'll talk about the mean and the median and how that relates to these in a second, is that because this is a little bit longer, we have what could be considered like an outlier down here that's pulling the mean down because there's only that one 18-year-old. So again, if I were to take that off, now the range between these two would still only be 1 year, which would be the same as it is right here. So the lengths of each section just kind of tells you the range of each little quartile, okay? And we'll look at kind of more examples of that as we move through the next couple examples, okay? All right, so when we look at this next one then, first thing we need to do is reorganize our data in numerical order. So 0, and then 2, and then 3, 2 4s, 2 5s, and 1 6. Okay. So the overall range is going to be 6 hours of TV. So let's figure out our 5-number summary, and then we'll plot everything on our number line. Okay. So I always start by finding Q2. Okay, so when I go move in, I've got 4 and 4 in the middle again, so I've got an even amount of data. So that means Q2 is going to be the average of 4 and 4, which is still just going to be 4. And then we'll find the lower and the upper quartile. So when I find the median here, it's going to be the average of 2 and 3, which is going to be 2.5. So here we're going to have a decimal. And then here, that's going to be the average of 5 and 5, which is just going to be 5. So again, I want you to just make sure you understand that after you figure out the quartiles, each little section that you have should have the same number of data values in it. So we've got 2, 2, 2, and 2. Here's another case where I would probably just go up by 1, starting at 0, since my range is only 6 hours. 1, 2, 3, 4, 5, 6. And I spread those out a little bit more. And then this is hours of TV watched. All right, so Q1 is going to be 2.5. So right there, my minimum, my least value is 0. And then I'll just go ahead and plot that right here. Usually I would write it like above this line right here, but I just don't have enough space. And then Q2 is 4, so I'll draw that line there. And Q3 is 5. So I'll draw that line there. I'll connect my boxes. Go out to my maximum, and then go down to my minimum. Okay? And so there would be my box and whisker plot for this. So this one's a little bit more like evenly spread out, I would say, as opposed to the backpacker one. You can see your boxes are a little bit closer to the same length. This whisker is still a little bit longer. Again, you've kind of got this 0 that's a little bit different than a lot of your other data values. You're jumping right from 0 to 2, which explains why this is a little bit longer. Okay. All right, and so now what we are going to do is do some more like interpretation. So we're done drawing box and whisker plots. So now would be a good spot, like if you want to take a little break, look at your homework maybe and like do the couple where you have to draw it, and then just take a little break from math, come back later, and then watch the next part and then answer the rest of the questions. So sometimes it helps. I know this lesson's going to be a little bit longer, so if you can break it up a little bit, it's never a bad thing. All right, so a couple other things that we use when interpreting a box and whisker plot are outliers and then the inner quartile range. So remember, the range again is the highest value minus the lowest value. So the inner quartile range is the range between Q1 and Q3. So essentially the start and end of your box would be the inner quartile range, which is abbreviated IQR. And so be careful when you're answering those questions that you understand which range you're finding. Because I could say, like, find the range of the lower 25%. So that would be here, this range right here. Find the range of the middle 50%, which is the inner quartile range. Find the range of the top 75%. So that's why it's important to make sure you understand how the box and whisker plot is kind of like broken up here. So if I want the range, that means I want the high minus the low. So if I wanted to do that, I would do 300 minus 160, which would be 140 seconds. So what that tells you is that the difference between the shortest and the longest song played at this concert is what, 2 minutes and 20 seconds. Okay, so then the inner quartile range is just the difference between 280 and 220, which brings this down to 60 seconds. So that tells you that the middle 50% of the data ranges between 60 seconds of each other. Okay. And so if you're looking now, are the data more spread out below Q1, so that would be this section right here, or above Q3? So whenever you're talking about being more spread out, you're analyzing those ranges. So if you have a smaller range, like we did here, our whisker was shorter. So that means that our range wasn't as big as it was down here. So we're essentially looking for, where is our data the most spread out? Where is my box the longest? Or where is my whisker the longest? Okay, so I can see right here, this whisker is longer than this one. So that means that they're going to be more spread out below Q1, which is the low 25% of the data, the first 25%. Okay. And it's because the whisker is longer. Okay. All right, so now we're going to come back to that idea of an outlier. How do we figure out if a value is an outlier or not? So back on the front, that's where I defined this. So an outlier is a data value that is significantly higher or lower than the rest of the data values. Okay. So there's like a little mathematical, I wouldn't even call it an equation, it's kind of like a mathematical relationship between the values on your box and whisker plot and how you find the outlier. And so what we do is we take that inner quartile range, the middle 50% of your data, and we're going to multiply it by 1.5. So we'll stretch it out a little bit. And then we're going to use the low value and the high value to determine if there's anything outside of that range that would be an outlier. So we're just going to look at that for this example. Most of the time, like, we can pretty much tell, like, this 300 is not going to be an outlier. And that's because this whisker is really not that long. But we've got this low value down here that's lower than most of the rest of these, so this could be an outlier. We just need to know the relationship between the 160 and that stretched out interquartile range. Okay. All right, so when we take 60 times 1.5, we get 90 seconds. Okay, so now what we do is we go back to Q1, which was 220. So if I subtract 90, because I'm working backwards here, so kind of instead of an equation, I'll just explain this in words. And so if there is a song that's 90 seconds or more shorter than this one, so if it's over here somewhere, that would be considered an outlier. Well, 220 minus 90 is what? 130. And so there is not a song that's 130 seconds. Our least value here is 160, which is only 60 seconds away from 220. And so this is not an outlier. It's not far enough away. And then if there was a song that was more than 90 seconds longer than 280, then that would be an outlier. But the longest song is only 20 seconds, so we go back to 280 and add 90. And so there's not going to be an outlier in this case. Okay. And so what an outlier does, and not even necessarily has to be an outlier, like I would consider this to match one of these descriptions, but if there is a whisker that's significantly longer than the other, then that skews your data. And so when we look at these three shapes, if your data is skewed left, that means that your left whisker is longer than the right one. And so what that means, kind of going back to this example here, is that there is a value that's pulling the rest of your data down. So if we look at 75% of our data, right, these three pieces combined, 75% of people are 23 or higher. But we've got this 18-year-old. And so when we think about what that's going to do to like our measures of center, this 18-year-old is going to make your mean lower because it's lower than your average data value. And so that makes this the relationship between your mean and your median. If a box and whisker plot is symmetric, that means that the whiskers are about the same length. They don't have to be exactly the same length, but they're going to be pretty close. And so that means that the mean and the median will be pretty close to each other. And then if your data is skewed right, that means that your maximum value is significantly higher than the rest. So if you think back to that example from yesterday, like with the hourly wages at the amusement park, we kind of talked about that there when we had that one wage that was like $16.50 or something like that, and that made our mean a lot higher than most of the data. And we would say that that value is skewing the, I'm sorry if you just heard my son announce that he had to go poop. This is what happens when you try to record videos with children at home. Never a dull moment. Luckily, I'm almost done, and then I will have a literal duty to take care of. All right, so I don't even remember what I was saying. We'll talk more about that, I guess, when we look at this example right here. All right, so we've got, this is called a double box and whisker plot. Right, obviously, 2 box and whisker charts kind of on the same number line. And so when we are identifying this shape, whenever you're asked that, that means I need to know, is it skewed or is it symmetric? So I can see here that this whisker is significantly longer than this one. So we would say that this is skewed left, right? This person's score is significantly lower than the rest. And so it's going to pull our mean down. It's skewing your data to the left side. Whereas this one, the range here is 10, the range here is 10, so this is actually exactly symmetric. Hold on, honey. This is exactly symmetric. Now remember, it doesn't have to be exactly symmetric. If it's off by like a couple, you could still call it symmetric. And oh, I remember what I was gonna say up here. You're not looking at the boxes to determine if something is skewed. You're looking at the whiskers. Is your minimum or your maximum value making your whisker longer? Okay. And so then, in terms of answering this last question, which test scores are more spread out? So we talked about that up here. I see that word spread out. We're looking for the range. What's the relationship between the ranges? So when I look at the range of our friends class, that's 40%. This one's only going to be about like maybe 32, 33%. We don't know exactly what that score is, but around there. So since our French class has both a bigger overall range and a bigger inner quartile range, that means that our friends class is going to be more spread out. I must just write 10 spread out. All right, you guys. And so hopefully there's no echoing this time. Your homework tonight is posted on Canvas, 9.2 worksheet. Let me know via Remind or Canvas conferences if you have any questions. See you guys later.